Lab 1, position versus time. Introduction. In this lab, we first record a video of an object traveling in constant motion without any change in direction. Next, we develop data using Tracker to analyze the position at several points in time in order to compute the constant velocity in which the object is traveling. Then we use GlowScript to code a predicted computational model with the same initial velocity and position. The main purpose of this lab is to compare the actual versus the predicted data and see if they both align with each other. This is the actual values and graphs of the position versus time in Tracker of my experiment. Ideas. The ideas being tested here are constant velocity and position. In order to be in constant motion, the object has to be in constant velocity, which means the acceleration equals 0. Equation 2 shows that if acceleration is 0, it means the final initial velocities are the same. The velocity is determined by the position divided by the time. The position is determined by time multiplied by the velocity consequently. Reasoning. The reasoning for explaining how to get velocity is because we need the motion to be constant, horizontal velocity versus time graph. Position is also explained because we need a constant change in position at a constant time interval. Surroundings, conditions, details, and errors of the experiment. The surroundings for the experiment were a dorm stairwell and the ball was rolled on a stair. There is minimal air resistance, but still considered an error. Constant motion cannot be achieved because the stair has friction, and my push on the ball served as an acceleration, which is another error. Initial conditions are a net force of me pushing the ball, and the ball eventually reaching constant motion on the stair step. Details of the experiment are me pushing the ball across a stair, and it's a soccer ball with the diameter of around 22 inches, which means around 1 meter. Or 0.1 meter, sorry. Okay, for the code, I first set my velocity to the constant velocity I found in Tracker, which is 0.33 meters per second. Then I updated the equation to the velocity formula. Final velocity equals initial velocity plus the acceleration. In other words, the net force divided by the mass times the change in time. Also, I updated the position formula to final position equals initial position plus velocity times the time. What if and what do you mean questions answered. For the what if question, I said if I change the x direction, then the velocity would still be constant, but would be a negative velocity since it would be negative x divided by t to find the velocity. For the what do you mean question, I said the frictional force and air resistance should be equal to the force initiated by the humans on the ball. The gravity and the force of the normal force of the surface should also be netted to 0. These are my graphs. So the predicted position versus time looks like this, and the actual position versus time looks like this. And these are both on the same graph. This line is a little off because the time intervals are different. There's a different number of x coordinates, but if you look at it separately, it looks almost exactly the same. Thank you. Lab 1.